All right. Doing 360s here. We can move them in whatever direction we want.
Hi everyone. So a lot of people ask me, how do magnets affect our body's blood? And so in these experiments, we're going to test out how magnets affect water, how magnets affect red blood cells that are separated from plasma, and how magnets affect blood that has been burned and converted into iron oxides. And so we have all of these elements here. We've got some powerful magnets. We've got a small propane tank, and we're going to heat up some blood. We've got some mammalian blood here that has already been separated into plasma and red blood cells, and we're going to separate those, put those in here, and we're going to see how magnetic fields affect each and every one of these. So let's begin. We're going to take this magnet, which has about 1700 Gauss strength, and we're going to see if it moves this water. And so wait a few seconds. 1, 2, 3, 4, 5. There's some slight movement, but not too much. So we're going to take these 3 neodymium magnets that have a combined total of about 2400 Gauss, and we're going to put them up to the water. 1, 2, 3, and before 4 seconds we see that it's already moving it. It's pushing it to the side, and so we then can take these, and before we use this side, it doesn't matter, we're going to use this opposite side, and we can stop it in its tracks, and we can make it move in the opposite direction. And so there, after about 4 seconds, it starts to move in the opposite direction. And hence, water, known as H2O, is what is called diamagnetic. It repels or is afraid of the magnetic fields. And now we're going to do it with even stronger magnets. Each of these magnets is about 2000 Gauss, and we have 1, 2, 3, 4, 5 magnets together that, even though they don't add up to a total of 10,000 Gauss, they do add up to over 4,000 Gauss. These are very, very strong, and so now I'm going to put these next to this water, and within about 3 seconds it starts pushing it. So the stronger the magnetic field, the faster and the more force that is acted upon the water, which is diamagnetic. So next up, we're going to remove this water, and we're going to suck out the red blood cells from this cow's blood here. So it's going to be interesting to see what type of reaction we're going to get from the concentrated red blood cells that have iron in them. And so red blood cells have hemoglobin. The hemoglobin molecule has 4 iron atoms per red blood cell. And iron is ferromagnetic. It responds to a magnetic field. So we're going to see how well this blood responds to a magnetic field. We're going to test it out with the 2400 Gauss. And it is being repelled, just like the water. And so our body contains about 70% water, and even though the blood is already separated into plasma and red blood cells, well, there is still a certain degree of water content as well as other minerals in there that may be diamagnetic. And so there we can see how it's repelled. And we're going to go with the stronger magnet. And once again, we observe the same diamagnetic repulsive effect. So once again, in answer to the question, how do magnetic fields affect blood? It has a diamagnetic repulsive effect. Okay, so here we're going to take this cow's blood and burn it using this gas propane tank. And we're going to convert the iron that's in the red blood cells as bound iron into iron oxides. And so we're going to see how that reacts to the magnetic fields. So now we're going to see what happens as we pour these flakes of iron oxides into the water and see how they respond to the magnetic fields. Now the iron is attracted to the magnetic field, and we're going to swing them around this way, grabbed on somebody else, and we're just going to get them moving in this direction. We just pulled another guy, and here we go. All right, doing 360s here. We can move them in whatever direction we want. And so, once again, we had to change the chemical characteristics of the iron that was bound in the hemoglobin that was not paramagnetic at the time. By heating it, we then created the iron oxides that released the iron and therefore brought it back into its ferromagnetic state, whereby it is attracted to a magnetic field. All right, so there you have it. By using magnets against blood in its normal state, it has a diamagnetic property and is repelled. By burning the blood and releasing the iron oxides, it then becomes paramagnetic or slightly more magnetic. And so what a fun experiment, and how much great information we learned today. You can learn more about how magnets affect our bodies by studying biomagnetism.